So you can register yourself using this code on Kappa website. Okay. Kappa have just donated us, sponsored us their latest software, Carbone, and also other software like for well completion, well testing, and protection logging. Okay. Our computer lab is in the process of upgrading, and inshallah soon we will have hands-on training on all of the module of Kappa. Okay. Today we'll go through one of their module that's called Carbone here. Okay. So what is Carbone? Is a simulator that helps us to analyze the reservoir fluid composition. Okay. But the question is, have you ever heard any company that are doing PVT analysis, reservoir fluid study? As a petroleum engineer, you can get a job in Kappa also, okay? And you can also get a job in PVT laboratories, okay? Have you ever heard any company that are doing PVT analysis for ADNOC? Okay, so I just, if we go here, the next page of the presentation, let's see here. You can scan this code. You will go to the website called Startum. Okay. Here you see Startum is a reservoir fluid study lab, and also they are doing core analysis and scale analysis. They also have a laboratory in Musafa, in their office. Their lab is also in Musafa and all over the world. Okay. So if you get a chance, you can contact them, you can visit them. For example, here, yes, Dr. Muhammad is here, and he just said that he's arranging a tour with Startum. So if anyone would like to join this tour, please contact to Dr. Muhammad. Okay. So if we look at their website, they say that they are having a full service for fluid analysis. Okay. And what they are doing PVT analysis. PVT means pressure volume temperature analysis. And then they further categorize. For example, they said they are doing gas condensates. They're doing volatile oil, black oil, heavy oil. Okay. They all are type of reservoir fluid. Okay. How many fluid we have in reservoir? 3. For example, oil, gas, and water. That's what we study all the time, that we have 3 fluid, oil, gas, and water. But there are subcategory also. For example, if the reservoir have a light oil, very light oil, we call it, you can say volatile oil. We can, if it's have a gas with the liquid, we call them gas condensate. Okay, which one is more expensive, gas condensate or black oil? Why? Condensate is heavy or light? It's a light. Okay, gas condensate is more light component in it. Okay, it's more expensive. Okay, and the black oil is more heavy and is less expensive. Okay, the point to tell you that why we are interested in this, in PVT analysis. Through PVT analysis, we can figure out if the fluid is gas condensate, volatile, or is a black oil. For example, we can find the API gravity. Have you heard of the API gravity? If the fluid is lighter, API gravity value is high. Okay, so we can find these properties in the lab. Okay, so the PVT analysis have direct relation with economy, with marketing, with selling of our crude oil. Okay, once we discover any reservoir, Okay, for example, we have geological survey, we have discovered a reservoir, right? And after discovering reservoir, next job is drilling. And after drilling, the first job we do is we send chamber inside the reservoir to collect the oil sample, and we send the sample to the PVT lab like the stratum. Okay, stratum are the first human being, you can say. They see the oil sample with their eyes. Okay, all are other just doing interpretation. Okay, like it's like you are sending someone some robot to the Mars, and then they're collecting the sample and sending to back to the Earth. Okay, so NASA will be the first people who will see it, right? The same, the stratum, they are the first people who they will look at the how it looks like. Okay, so they take sample. It's not Stratum who are going to take a sample. It's the other company like a Schlumberger, Weatherford. They're going to take a sample. We call them sampling units. Okay, and they send sample. They collect sample through wireline tools. So all these details I will explain you during today's presentation. Okay, so this presentation is kind of series of presentation. Today we will have introduction to PVT plus the simulator or software. The next presentation will be about how to use software and how to analyze that data. Okay, so let's go through the presentation here. I don't think you can recognize this guy. It's me. Okay. This is my picture from 2007. Okay, so I just put intentionally this picture because I got this job just after graduating from the university. Okay, when I finished my bachelor, I get a job in ResLab Norway. So I joined ResLab Norway as a PVT engineer. Okay, so I'm standing next to the cryogenic apparatus. That was my master thesis. Okay, so I'm working. You see, we changed a lot. So there's a logo for ResLab. The ResLab was sold to Weatherford Laboratory, and then nowadays they call Stratum Reservoir, but they are same lab. But they started a small lab in Norway, and then they grow internationally. Okay. So you can see behind this operator here, there's the GOR meter. This is called GOR meter. We also have a small GOR meter in our PVT lab here. The GOR meter, what they do is to separate oil and gas to calculate how much gas will produce per barrel of oil. So this apparatus we use, this is called GOR apparatus. And this apparatus, this was my master thesis that we designed to analyze the gas condensate by using cooling effect from liquid nitrogen. Okay, we'll go inshallah to more details. Okay. So here's a website for Kappa. Kappa is a workstation. Workstation means they have many other software like reservoir modeling, well testing, and fluid modeling. All software, all engineers, they work on it. Okay, for example, well testing engineer will work on well test module, PVT engineer will work on PVT module, and reservoir engineer, but they can integrate their data. So it means what we're gonna find through PVT analysis, other engineers will use it. Not only use it, they are 100% depending on it. If we are not doing accurate analysis, it means their analysis will be also wrong. Okay, so they trust us as a PVT engineer, as a reservoir fluid study engineers to do the analysis properly. Okay, so what type of analysis we will have? Let's see. So introduction, this is the link for Stratum. PVT analysis, pressure volume is used in oil and gas industry to evaluate the property of reservoir fluids. Properties of reservoir fluids. Do you know any property of reservoir fluid that we can be interested? API. Porosity and permeability is not part of reservoir fluids. It's a rock property. Okay, so we are interested in reservoir fluid property in reservoir fluid lab. Any other property? Density, viscosity, anything else? Boiling point. Boiling point, yeah. Pressure. Which pressure we are more interested as a petroleum engineer? We are always concerned about that pressure value. Reservoir pressure we know from the discovery, okay? But there's one pressure point that it's already on the surface, then the oil is on the surface. But there's a very critical pressure point that we, as a petroleum engineer, we are very much concerned about it. The pressure that can force us to change all the facilities on the oil field. You know, facilities mean lot of separator, lot of processing unit, lot of pipelines. There's a pressure value that can force us to change whole infrastructure. At that pressure, the reservoir produces first bubble of gas. What is called? Bubble point pressure. Bubble point pressure. Okay. Naturally, reservoir that exists in the nature is very high from the bubble point. That's why we produce them homogeneous. Okay. Reservoir are like if you shake a Pepsi bottle, reservoir are like that. There's oil and gas are mixed with each other. It's like a Pepsi bottle. And if you open it, like after drilling, they can produce automatically. Okay. But if we reach to the bubble point, the oil will get separated from the gas. Okay. Then we will lose the energy. Okay. So as a petroleum engineer, as a field development engineer, as an economist, okay, as in charge of whole company, the most important thing for us is after discovering the reservoir to know what is their bubble points. Okay, because if we can maintain the reservoir above the bubble point, it is beneficial for us. Okay, so that's why we do the PVT analysis. This is the main thing for, okay. The other things are like how many separator we should put, what should be the pressure, what should be the flow line. We call it separator test. That's another thing. But the first thing that we are more interested is what is their density as a tank barrel on surface, because the customer will give us money based on density and the composition. Okay. And the second thing we are more concerned about is bubble point. Okay. So this is the main purpose, the initial purpose of PVT analysis. Okay. So let's move further. Reservoir fluids. What we are doing PVT analysis, all we are doing on reservoir fluid, right? So here you can see this rig here. So after drilling, we are reaching to in the oil zone. Why we did not produce from the gas zone? You see there's a gas, there's oil, and there's water. Why we are interested in oil here? Why not first produce gas, then oil, then water? Any idea? Drive. Gas is pushing oil downward, okay? So we can produce oil. This is very imaginary diagram, okay? Like there's a gas, there's oil, there's a water. But normally, oil and gas are mixed, okay? And this is after the bubble point. This situation comes after the bubble point, okay? And you can see the oil can travel through porous rock, and it means this area is not a bubble. There's a rock there. There's a rock, okay? There's porous rock in the reservoir, okay? So we are interested to know what is the density of reservoir fluid at reservoir temperature and pressure, okay? What will be the viscosity of reservoir fluid at reservoir temperature and pressure, okay? For example, if how much pressure is in the reservoir normally? Any idea? 2000 psi or bar? Yeah, I work most of the time in a bar, so yeah, if you multiply bar with 14.7, it becomes psi. Okay, so for example, it's around 3000 psi, more than 2000 psi. Okay, how much pressure is in your car tire? 30. You can compare 30 versus 3000. It's a very high pressure in the reservoir. So in a PVT lab, we try to create the same condition that we have in the reservoir. Okay, so it means in PVT lab that we have downstairs, we can build the pressure up to 3000 psi. It takes a lot of care. Okay, and we can bring the sample to the reservoir condition. Okay. So let's move. Once we drill in the reservoir, the next job is to collect the sample for analysis, right? So we have different methods to take a sample from the reservoir. Okay. The most important thing when we are taking a sample from the reservoir is that the sample should not get contaminated. Okay. We need to have it in real form. Okay. The example is maybe some people don't like it. For example, when in hospital they take your blood sample, they take it with extra care, right? They have vacuum tube. They take it with extra care. Why? Because they don't want it to be contaminated. So, the same way, we send a vacuum chamber, and we call it MDT chamber. They have different type of chamber, okay? But MDT is more famous, module dynamic testing chamber. They are from Schlumberger. We send them in the reservoir to collect the sample, okay? But if there's a high temperature and high pressure, then we also can collect from downhole from the reservoir, okay? And if the reservoir is already built, everything is done, maybe after 10 years, 20 years, we want to take a sample again, we do from the surface, from the separator area, and then we remix them, okay? The thing is that why PVT, all the PVT lab are doing business. They are doing testing all the time, right? For example, in a hospital, when people get sick, okay, they do the test, they make money. This is life, okay? But why we are sending sample all the time to the PVT lab? Once we drill the reservoir, we figure out the property class. After 40 years, 30 years is enough. Why we are doing this test every 3 months, 6 months? That's what. Very good answer. Because we are concerned about bubble point. How far we are from the bubble point. We always detect. Not only as an engineer, a lot of agencies, the government agencies they are interested, where are we at the bubble point, okay? So it's a compulsory for the companies to do the test from the third party. Maybe the question is in your mind, why ADNOC, they don't do the PVT analysis, okay? Because the government requirement, you need to send the sample to the third party. You can do in-house, no problem, like Saudi Aramco, they have their own PVT labs, but still they need to send sample for third party, just to have confirmed results, more trusted results, okay? That's how private companies are working in PVT business. And as a petroleum engineer, if you want to do a business, you can also start PVT lab. It's also one kind of business idea. Okay. So here you can see we can send a chamber, bottom hole in the reservoir, and then once we collect the sample, then the next job as a PVT engineer, as a reservoir fluid engineer, is to take sample out of this chamber and put in a PVT bottle. Okay, you take a sample from a chamber, because chamber is not practical, is very lengthy. Okay, plus is more expensive, so rent is very high. Okay, so the first job that we do is to remove the sample from the collector chamber to the lab bottle. The lab bottle, we call it PVT bottle. Some company call it cylinder, some company call it bottle. So here you can see it's written ProServe. ProServes are the manufacturer of PVT bottles. Okay, PVT bottles, I just want to share here. PVT bottle have a piston inside. One side is glycol, like water, and other side is oil sample. Okay, because when we transfer sample from chamber, because chamber have collected sample as reservoir condition, right? Temperature and pressure, and we transfer sample from chamber to the bottle. So we want to keep the same condition here also, higher than the bubble point, because the fluid have some natural structure, right? If we collect the sample from a reservoir and decrease pressure or bring it to phase, sometimes there's a wax precipitation in the sample, and it takes like 5-6 days or 7 days conditioning to bring it back to the reservoir condition. Okay, so that's why we use PVT cylinder to transfer sample at high pressure to the. This bottle can handle up to 1,000 bar pressure. 1,000 bar pressure means 14,000 psi pressure. So extremely high pressure. Okay. Normally, companies, PVT lab companies that don't own these bottles, they prefer to get on rent because it's a high risk involved in these bottles, high pressure bottles. So high risk is involved there. Okay. So here, once we collect the sample, we do the conditioning, and after the conditioning, we can start the lab experiment. Okay. Now we are moving toward the lab experiment. We have collected the sample from the reservoir to the chamber, and through the chamber to the PVT bottle, and after conditioning, the sample is ready for analysis. Okay. We can do a lot of analysis. Okay. It depends on the invoice, what type of analysis company wants, and which information they are interested. Okay. For example, here is written chromatography. Okay. Normally, the first test that we do is chromatography of oil and gas. Anyone have any idea why from this word? Can you check your water bottle? There's written composition of the water, right? Through chromatography, we can do we can find the composition of the oil. Okay, how many light component? What's the name of the lightest component of the hydrocarbon? Methane, right? And then we have ethane, propane, butane. In one drop of oil, there are thousands of components. Okay, there are thousands of components, but we are just interested the one who are in high quantity. Okay, for example, in this water bottle there's water, and then there are some minerals, right? But maybe there are also traces of other minerals, but we are not interested. That's why they just report what are the highest quantity. Okay, so we can do the composition analysis, and how we can find the composition. It's a very interesting experiment that we do in PVT lab. We call it gas chromatography. Okay. For example, if I ask all of you, okay, if I ask all of you, not you guys, okay, I will change my word. Let's say there are some thin people and there are some heavy people, and I ask them run. Who will run fast? The lighter will run fast. Okay. And if there's at the end there's a security guy, he will catch him, right? The same is in oil. Oil have thousands of components. Okay, we will put one drop of oil in a very, very thin pipeline, like here, very thin pipe, and we push this oil sample with the inert gas. We have helium, nitrogen, inert gas, any inert gas. Okay, we push them, run, and when they will run, the lighter component will reach at the end first, and then the second, then the third, then the fourth. And we put them fire. From the flame and heat, we can figure out how much quantity of this component is in the one drop of oil. Okay, that's how we can figure out all this composition. You see, there is a mole percentage, how much liquid is there, right? And we do this through the gas chromatography. You see, there's an experiment. Here we have inert gas, And here we inject the sample, and then the sample can travel through this pipe, and then we can get fire. And here we can find from the graph which component come first and how much percentage. So we can figure out the composition. This composition is very important. Okay, like when you go to doctor takes your blood test, and then doctor can simulate your health, right? Can figure out your health only looking at the value of your blood report. Okay, same is PVT simulator. In PVT simulator, we give this composition, only this composition. Okay, and there are mathematical equation of states, okay, from different scientists and engineers. With the help of their different equation, we can find the value properties of reservoir fluid that we can find in the lab. Okay, so they can give us like a prediction that these are the property of reservoir fluid. Okay, just to confirm, we do the lab test. So we have a lab test plus we have a simulation, then we can match each other. If they match each other, it means we are on the right path. If they're not matching with each other, it means we need tuning of our PVT lab data. Okay, and this is another topic we will discuss in the next. Okay. So let's see. After doing this, the second experiment we do in the lab is to find the bubble point. Okay, how we can find the bubble point? We put sample in the chamber in the PVT cell. We expand them and we look very carefully when the first bubble of gas will come. Okay, so let's see here. Let's see here, we have oil sample. Okay, and here we have oil sample. And if we move the piston, the oil will expand. We can take value here, P1 versus volume, right? P2, pressure is decreased. If you look at the graph, pressure is decreased, but volume is increased, right? And then P3, P4, we can make a straight. Once we reach to the gas bubble, the volume will expand more because of the gas compressibility. There will be less decrease in pressure. So we will have two plots. So in single phase, the graph will be like this, and two-phase graph will be like this. If we cross the line, we can find the bubble point. Okay, this is bubble point. Is the reservoir condition, is reservoir temperature and pressure. Okay, but because taking a sample is very expensive business from the reservoir. Okay, so let's say if we only take one sample, maybe it's damage, maybe it's a loss. It means we have lost maybe at least $500,000 to $600,000. Okay, so what the company do? They take around 4 to 6 samples. Okay, and they send to the lab for. First, we do the bubble point at the room temperature just to see which sample are more consistent. Okay, and then we run this test at the reservoir condition on the selected sample. Here's written constant mass expansion. Okay, so because we are not changing the composition, we are not removing anything, so that's why this experiment is called constant mass expansion. And then and later on, once we have you see, we have gas chromatography, and then we have bubble points. Okay, once we take a bubble point, the sample is ready to put in a GOR meter to separate oil and gas, and we can figure out the density of oil. Okay, so we have a lab experiment done, and now let's move toward a PVT analysis simulator. Okay, so how many experiments we have done? We have done gas chromatography. What is that? To check the composition. And And what is our second experiment? To find the bubble point. Okay, and we are not sure if this experiment are done in the correct way or not. Okay, because there's always human error and contaminations. Okay, so we need to fine-tune the data. We need to verify if our experiment are correct, if the sample we have analyzed we have done in a proper way, and that's why we need PVT simulator. The first job PVT simulator is doing to verify our experiment, and the second job the PVT simulator is doing to give us the result that are for the experiment that are not still done in the lab. Once we are match initial data, then we can predict the future data also. Okay. So here you can see from this figure, I have taken this one from the from the website, from Kappa website. Okay, you see here. Before next presentation, please go through the video tutorials. Okay, they have a lot of videos here. I will show you, but you can only access once you have account with them. Okay, and here is the flow chart. You see, first thing, they can model the composition. From composition, they can model the two-phase diagram. They can construct the two-phase diagram, and they can tell us what could be the saturation pressure, the bubble point pressure. Okay, and we can also find some other property like compressibility, viscosity, density using the simulator. And we can also do the VEX precipitations. You know what is VEX? VEX precipitation. VEX. What's that? Yeah. Some fluid, when we lower the temperature and pressure, they produce jelly type fluid. Okay, and that's not good for the pipelines for transportation of the fluid. Okay, so we also need to do the test in the lab. Okay, asphaltene modeling is also the part of this, but most of the time PVT lab we use it for black oil modeling. Okay, and we do the quality check of the lab data and the QC. Okay, so let's see how we can do it. Okay, here I'm just giving you the introduction of this, how it will work. Okay, so let's move forward. Okay, for example, we can run this experiment in the lab. Okay, and then we can simulate this experiment also through the simulator. Okay. So what is the first experiment is constant composition expansion. What is the benefit of this? No, constant composition expansion is the same exactly. Is also they have two names because I took this from the website. It's the same name is constant mass expansion because we are not changing the composition. So through this test we find the bubble point. Okay, then we have constant volume depletion CVD test. Okay, for example, if we have a gas condensate reservoir, we are producing gas, right? But this gas is also producing liquid when it comes to the surface temperature. Okay, and it's also leaving liquid in the reservoir. So how they are leaving, how much liquid they are leaving in the reservoir, we can test through this test, constant volume depletion. Then we have saturation pressure, the same bubble point. And then we have differential liberation, that how the composition will change if we are above the bubble point, and how the composition of oil will change during production. We can find through this test. Okay, and then we can also do the test for at which pressure and how many separator we should install in the field. Okay, and we also have a swelling test is related to EOR, enhanced oil recovery testing. So let's start. Let's say we have started the Carbone. Okay, what you need to do, you need to first give a name and put the initial condition and reservoir condition. Okay, and we'll do this once our lab is ready. We'll do this tutorial in the lab. Okay, so I just want to show you it's not difficult. It's so easy. Okay, we have given the name of the test, some initial properties like what is reservoir temperature and pressure, and after finishing that we can upload the composition. And composition, from where we got this composition? From gas chromatography. Okay, so the composition we have from gas chromatography, we can select the component that we are interested to model. For example, we are interested until C15. Okay, and then we can copy from our gas chromatography report, we can copy paste this composition to the simulator. Okay, so once we put our composition into the simulator right away can give us the phase diagram. Okay, so in the phase diagram there's 2 points. One is here, one is here. There's 3 points, 1, 2, and 3. And because the text is so small, but can you identify what are these 3 dots? 1, 2, and 3. We have just what is two-phase diagram? Anyone? Pressure and temperature diagram. What's the benefit of this diagram? Bubble point and how the composition of the fluid will change versus pressure and temperature. You see, we have just given the composition to the simulator, and the simulator is giving us value about how the fluid will behave versus pressure and temperature. What are these 3 dots? 1, 2, 3. This is phase diagram. Anyone can guess? We have only 5 minutes more. Okay, so we finish soon. So this is reservoir temperature, pressure. This is bubble point pressure. Okay, and this is a critical pressure. Reservoir pressure we have given. Bubble point pressure is figured out by the simulator. You see, we have bubble point here, and also we have bubble point from the lab, right? So we can compare if they are matching or not. Okay, and then same we have critical pressure. What is that pressure? When we cannot differentiate between liquid and gas. Okay, so let's see, we have composition. If they are not matching, the problem is with the heavy component, because the gas chromatography can give the accurate composition of the light component and have an issue to give the composition of heavy component because they are in a very little amount. Okay, so here with the, let's say, C plus 15 plus, we can play around and we can tune the simulator by changing this value. And this we will do in next exercise. We will run the simulator and we will inshallah go through it. Okay, let's see, we have done the bubble point in the lab. We can also upload this information in the simulator, and the simulator can give us trend about the viscosity, density, all the information, and then it can tell us, for example, this value, the red line is by the trend from the simulator, and the dotted line are trend from the lab, and these results are not accurate. So it means we need to tune the data. We need to figure out where is the problem. Okay, so this, where is the problem, we need to figure out in the next lecture. Okay, if we call it tuning the PVT lab data. Okay, so any question? You're welcome. Thank you very much for coming. Just register on Kappa website and go through tutorials and learn about it. And if anyone is interested to use this software, Right now, we have on one computer as a server because our lab is in upgrading, so we can't install in all computer. But still, we have on one computer. Okay. So if you are interested to use the software, please contact me. Okay. Thank you. Thank you very much, all of you who are online. Shama, Khalud, Engineer Arwa, Majid, Meta, Amil, Wad, Engineer Hani, Engineer Hussam. Thank you very much. If you have any question, please feel free to contact me, okay?